Hi, I'm Jimmy Wren, Product Manager for Bridging at ATTO Technology. This brief video will touch on several of the use cases that fit best for XstreamCORE solid-state storage controllers that allow SAS devices to connect over Fibre Channel or Ethernet fabrics. It's a purpose-built product made for converting protocols at an accelerated rate. Now, one of the first use cases that the XstreamCORE was built for was taking multiple SAS JBODs and turning them into Fibre Channel connected storage for NetApp's Metro Cluster business continuity solution. This allowed NetApp to use JBOD shelves with data on tap software-defined storage, while XstreamCORE provides extremely low latency, allowing synchronous writes to data centers that are hundreds of kilometers apart. Previously, this was done with Fibre Channel drives, but now we make SAS JBODs look like a Fibre Channel JBOD. Now, a recent use case revolves around storage disaggregation. This is where you separate compute from storage. One of the use cases here is adding storage to blade servers, which typically have limited space for drives, and applications really do not need the features of enterprise RAID or all-flash array storage, or the cost. Storage owners can use XstreamCORE to add and map externally connected hard drives and SSDs to individual blades, allowing them to expand storage where they could only support maybe 2 drives per blade previously. Adding XstreamCORE plus JBOD storage allows scaling of storage for use by these blades with software-defined storage or as high-speed cache. This can be connected through the onboard frame network connections or with a mezzanine card for Fibre Channel for the Fibre Channel models. With the model of hyperconverged storage, we see limitations in performance in and out of nodes, as well as node capacity issues and the inability to scale up storage when only storage is needed. Typically, a storage owner must also add another node, which has added server hardware and licensing costs. Since XstreamCORE connects SAS storage over Fibre Channel or Ethernet, you can connect up to 64 nodes to up to 960 drives, making scaling of storage as easy as adding another JBOD. So if you only need a few nodes but a lot of storage, XstreamCORE can help that in hyperconverged configurations. Now, here performance can also be a concern. Since most storage servers have fixed connectivity to storage inside the box, there may be 8 12-gig SAS PHYs on a PCIe 3x8 bus connected to an expander with 16 total 2 terabyte drives. This equates to 250 megabytes per second per terabyte. If capacity needs to be scaled, it means buying a new server or replacing these 2 terabyte drives. If these 2 terabyte drives are replaced with 4 terabyte drives, and even though the capacity is scaled up, the performance of these drives remain at the same consistent rate. The once 250 megabytes a second per terabyte of storage now turns into half that at 125 megabytes per second per terabyte of storage. XstreamCORE allows a disaggregated model that allows performance and capacity scaling to multiple host nodes. Now, remote connectivity to SAS tape is another use case. SAS tape libraries over Ethernet or Fibre Channel connected with XstreamCORE is another use case that's been gaining popularity of late. Many CSPs and MSPs still use tape as an inexpensive long-term method to keep archives of their customers' data. With the massive installed base of Ethernet storage devices, being able to add SAS tape drives and libraries to the Ethernet network is highly desired, giving them a single protocol to manage in the data center. The speed and capacity of tape is increasing and expected to eclipse hard drive capacity. It is becoming a more desirable option for cloud applications where data is being generated at a fast rate, and archive storage options that are expensive make it difficult to keep up with budgets and generate higher margins. That is really something that we're kind of surprised with, but tape is making a pretty comeback in certain segments of the market. Now, one of the sweet spots for this controller is to use attached SSDs as cache storage for up to 64 hosts. This will give a performance boost with drives that can be assigned on the fly to compute nodes as needed. One example of this is compatibility with VMware's Virtual Flash Read Cache, or VFRC. This allows external read cache with multiple paths to storage and boosts performance up to 145% without having to reconfigure servers or add SSDs to multiple servers. VFRC has gone through many changes and improvements, which shows its best face in 6.7 of ESXi. It's got multipathing, it's got many different features, including Fibre Channel support that helps that. All of the current XstreamCORE offerings have 4 12 gigabit wide lane SAS ports, which are bridged to 2 or 4 16 gig Fibre Channel ports, 2 32 gig Fibre Channel ports, or 2 40 gig Ethernet ports. With our advanced technologies like the XScore hardware acceleration processor, eCore offload processor, and an intelligent bridging architecture, XstreamCORE provides speeds up to 6.4 gigabytes of throughput and up to 1.2 million 4K IOPS per controller for these use cases and more. Now, controllers are usually connected in pairs for high availability, so you can double those performance numbers. I hope this series of videos helped to explain XstreamCORE. If you need more information, visit ATTO.com. Interested in a free evaluation of XstreamCORE? Contact your ATTO sales rep for more details.